All right, so there are two kinds of friction, which is dynamic friction and static friction. So how do we define if it's static friction or dynamic friction? Yeah, exactly. So like when I'm trying to push an object like this, and when I'm pushing it, it's not moving, then it's static friction. When it starts to move, the friction will be dynamic friction. So how do we explain this graph? So when we take a look at this free body diagram, when it's not moving, the force when I apply to this object should be the same as the friction, right? So when this object is not moving, I apply 1 Newton, the friction will be 1 Newton. When I apply 2 Newton, that'll be 2 Newton until they start to move. So that's why the graph looks like this. There's a linear relationship. When the applied force increases, the friction increases. Yeah, is that too easy for you? I think so. Yeah, so the formula will be like this. That will be friction equals to coefficient of friction times normal force. We can use this equation to calculate the maximum static friction and also the dynamic friction. And each have its own coefficient. So for today's lab, we're trying to find this, the maximum static friction, the coefficient of it. Okay, so that's the formula we're gonna use. So friction equals to coefficient times normal force. And the setting will be like this. So let me zoom in the camera. All right, the setting will be like this. You got a block, which have 4 kinds of shoe sole. So like the orange one, 2 black one, and a gray one. Right, we're trying to find the coefficient of friction of these 4 shoe soles. And also we got 2 surfaces, which is the tile one and the wooden one. So you got 2 surfaces, 4 shoe soles. What we're trying to do is to put a block on the surface and trying to increase the degree, the slope degree. So when it starts to move, like right now, I think, yeah, like right now, you're gonna record the angle of this slope. And we're gonna use that angle to calculate the coefficient of friction. But how do we use that angle to calculate the coefficient? We're going to do some free body diagram. So that is a setting like this. We have an object here. And there are several forces, right? The first one will be mg, the weight of the object. And also there will be friction parallel to the surface. So there will be friction. And how do we solve this problem? The first step will be to divide the force onto the direction that we are interested in. So we're trying to divide this mg into the direction here and the direction here. Why do we want to do that? Because the force on this direction will be the normal force, right? Which is needed in the equation. And also, this force is parallel to the friction. So we can directly check the relationship. So, use some trigonometry, we know this is theta, right? So here will be theta as well. So the normal force will be mg cosine theta. And also, the force here will be mg sine theta. And when it's just about to move, we know mg sine theta is the same as friction, right? So we can put the equation like this: friction equals to coefficient times normal force. And the friction right now would be mg sine theta, right? Which equals to mu that we're interested in multiplied by normal force mg cosine theta. So do some magic. Mu equals to mg sine theta divided by mg cosine theta. Okay, see that? Right, again, how do we solve the problem? Identify the force, which is the weight and the friction. We divide the weight onto two directions. One is vertical to friction, the other is parallel to friction. And when it's about to move, this one will be the same as friction, right? And this will be the normal force in that situation. So when we plug everything into this equation, F equals to coefficient times normal force. Friction will be the same as mg sine theta, right? The force parallel to the surface. And also, normal force will be the one vertical to the surface, which is mg cosine theta. And you do some magic with the equation, you got this one. And we know sine theta divided by cosine theta will be tangent, right? So that will be tangent theta. That is the equation we want to use today. So by getting the angle when the object starts to move, put into tangent, you got a coefficient in this situation. Super simple, right? Any questions for now? No? Cool. So that's all the concept we need. And actually this free body diagram and like those equations are just the same as the questions on your assignment, number 1 and 2. Yeah, so it's basically done. Back. So that's how we use this equation and the free body diagram to solve the problem. So when we understand the concept, what we're trying to do is to get the angle, again, to get an angle when the object starts to move, put the angle into tangent, you got a coefficient in between the shoe sole and the surface. So we're going to divide into 2 or 3 groups. I think 2 would be good because it's hard to do with only 1 people to manipulate this and record it, the angle. So we're going to divide into two groups. And we have 4 kinds of shoe sole, 2 surface, and also we can change the weight of the block. So we got 2 weights. So I like unscrew this one, open it. There are several metal plates in the box. So the first weight will be the weight already in the box. The second weight will be putting all the metal plates on the table into this block. So when you choose your table, you'll see how many metal plates you have. So again, there are 2 weights, 4 shoe sole, 2 surface. So totally it will be 16 situations, right? And for each situation, we're going to check it for 3 times. So we're going to do 3 trials. So you'll see that table on your manual, right? So you can see that's the first surface and shoe sole 1, 2, 3, 4. And in each shoe sole, you got different weights. So that'll be the first weight, the second weight. And for each situation, you're going to take 3 trials and take an average of it. So there are totally 48 situations. You're gonna like raise the slope, record the angle, raise the slope, record the angle, 48 times. So that's what we're gonna do today.
How long has that taken the other classes to do?
Actually, it's pretty quick as long as you got it like systemically. So probably 20 or 30 minutes. Okay. Yeah, would be cool. Okay, good exercise. So how do we get? Oh yeah. So yeah, that's it. And so we're gonna like when you put the metal plates in it, we're gonna weight the object. So there's a weight scale outside. We're gonna weight it 2, 3 trials for each set and record the angle of the slope and calculate the coefficient. So for the assignment, there are 2 tables and there are only 5 questions and 2 questions are already here. So you got only 3 at home. So yeah, that's it. Any questions? No? Cool. So we're gonna meet outside and one group will be in 2, the other will be in 3, I think.